My name's Harry Manley from the University of Salford. This presentation is about technology, but whilst we've heard some fantastic presentations this morning about the technology related to engineering, this is a software solution, which I am going to demonstrate live to you in the course of the presentation. We've also heard this morning about the concept of digital twin. Of actually modelling the railway environment so that we can do useful things with it in technology solutions. This is one application of using all that data that can be captured and digitised from the railway environment to provide practical real-world benefit as a result of that data. So, let's see if we can... What have I done now? Have I killed it? I've killed it. I've not. So let's try that one. There we go. Okay, so this solution sits fairly and squarely in the realms of BIM. There's a department at the University of Salford called the THINKlab, which has a specialism in the built environment and in using digital solutions to model the built environment. We probably all know about the mandate from government to implement BIM solutions and use BIM in the context of public sector buildings and public sector infrastructure. The work that we've done is also an attempt to respond to the challenge from government to provide better value from the £40 billion of planned investments in track infrastructure through CP6. Generally, it arose out of a request from Network Rail about 4 years ago to look at a specific track engineering project, a renewal project on the West Coast Main Line, and to look at the way that project was being planned and try to provide greater assurance in terms of safety, common understanding of all of the stakeholders involved, multiple stakeholders on that project, to try to optimize the cost and the output of that work, and also to make sure it was delivered on time. So those are the general objectives, but more specifically, this specific project required a 9-day blockade of a section of the West Coast Main Line. And two different groups within Network Rail thought that it was best done like that. Other groups thought it could be done with less disruption in a series of smaller possessions. And this solution was initially built to try to model the different scenarios and see which of these solutions would actually work best. So that's where it comes from. We've been working now with Network Rail for 4 years on a series of different projects where this software has been deployed. And the way we work is that each time we have a new project, it's generally an opportunity for us to add more functionality into the overall software solution. So it's been building, it's been getting better, and I'm planning to show you a demo of where we've got to today. Now, where this got started from is really a review of the planning tools that are traditionally used for planning possessions for engineering projects. And the conventional approach, which is still to a large degree the approach that's used in practice, is to construct a project plan using fairly simple traditional desktop project planning tools, Microsoft Project, possibly the P6 Primavera solution, a more sophisticated multi-user solution, but more often than not Microsoft Project, to build a Gantt chart of the main activities that take place. But of course a Gantt chart doesn't represent the physical space, the physical challenges and constraints within a rail environment. So that aspect has normally been left to the creation of a series of staging diagrams to represent the movement of physical assets such as cranes and diggers and engineering trains through a railway site and try to model that over time. So even on a 56-hour possession, there could be tens, maybe not 100, but certainly tens of different drawings that are produced to represent the position of things at various points in time over that work. On a 9-day blockade, obviously infinitely more complicated. So, this is actually hugely inefficient, and we looked at that at the University of Salford and we thought we could do something better. And the solution we've developed is to try to do something better. And we saw the solution as being composed of 3 main elements. First of all, modelling. So the ability to build and quickly and efficiently build a model, 3D model of the railway environment. And we'll talk about the inputs into that model on the next slide. But what we've done is first of all, we've made the creation of a 3D model efficient. so that it doesn't require technical people, software people to go beavering away in dark rooms for days and days and then come back with a solution. We've got this down now to about a day's work. We're almost at the point of being able to automate that completely, so it's a few button presses. The models are constructed from data which is held by Network Rail within the Orbis project, in a system, mostly in a system called GeoRhythm, which provides us with 3D models of terrain, a 3D terrain file. We also get aerial imagery, so we can create a more realistic texture, if you like, to the 3D environment we're working within. And also, the main other aspect is a series of GPS coordinates that represent the waypoint, centerline positions of the actual track. And from that, we can derive the positions of switches and crossings and so forth, and create an accurate 3D model of the environment. So the modeler takes these inputs and it builds a 3D model, which we'll see in our demo later. So that's the first bit. The next bit is a planner. So the planner is a planning tool that allows the rail engineer or the rail planner to do the kind of things that you see on the left, to build the plan. You know, to specify the movement of cranes and diggers and trains through the site, to specify where personnel are going to be working, maybe to mark out areas of electrical isolation at different times during the project. So the planner allows a user within the rail industry to define the plan. Now, this is a departure from the traditional approach to modelling and simulation for these kind of projects. You know, modelling and simulation has been used before for this kind of thing. It's not a new idea. But most other solutions that have been created, again, relied on software engineers to go and model the plan. Technical people to actually sit and take a plan that had been given by a rail engineer and then build it into a 3D simulation. So what we did is we created a tool which allows the railway engineer to, in a hands-on way, to define exactly what the plan is and integrate that with a three-dimensional model. And then what we have is the viewer. And the viewer creates a 3D realistic simulation that you can view from any angle, any perspective, to see what's going to happen and what that work is going to look like and feel like when it really takes place. So these are the three elements that we have built. So key features, so 3D representation of the site. Beyond that, we also have a library of engineering resources and activities. So what that means is when we talk about diggers and cranes and these various other assets, we have used and imported into our solution CAD models which have engineering accuracy and also information about the activities that those different pieces of machinery can perform during a piece of work. And the user, the planner, can select from that palette, if you like, that library of resources, and use that in the construction of the plan. And that incorporates shape and cost to the performance of those assets. So we get a more realistic and more accurate plan as a result of having all the information there and available. You begin to see there a picture of what the software looks like, but we'll see that when we move into the demo. So projects completed. There's been around 15 uses of the thing so far that are projects that have actually been completed through to the end of the actual engineering work. We have a few in progress at the moment. Most of this work has been in the delivery stage. So our engagement has mostly been at grip stages 4 through 6, with the people involved in actually delivering these projects. Recently, though, we've actually started to work on projects at an earlier stage, grip stage 1 to 3, more in the optioneering phase, where there's been a requirement to model different types of designs. And that's interesting and takes us off in some new directions in terms of the functionality that's called for. So we think it's been broadly successful. We've had good feedback from users. However, we certainly, we could do this more, and we believe what we're working towards is a new way of working, if you like, that could maybe in the future become a standard within the industry. So I'm now going to toggle to my own laptop so that we can start to see the demo. So the first thing to note is that this is running on a laptop. It doesn't require, a supercomputer somewhere. It's all pretty simple stuff. You need a reasonably powerful laptop, but it's nothing particularly special. The software is built by us. What we normally have is we receive a request from Network Rail normally for a model to be built for a particular site. That's defined in terms of the geographical extent of a particular site. The site we're looking at there, you see an aerial imagery of a site that's about 2 kilometres long. In practical terms, that's about the biggest site that you would want to have within one particular model. And you go beyond 2 kilometres, it tends to be a little bit tricky to navigate through the site, as we'll actually see. We could build more functionality to make that easier and enable bigger sites. It's not really a technical limitation on the size of the site. But the software is then created, it's incorporated with the model of the site, and then a user can download that and then work with it locally on their PC. So, what we have is an overview. And as I just zoom in, you'll start to see some evidence of what's going on here. So you can see the aerial imagery, and you can see the railway flowing through that particular cutting there, I think. But you'll see embedded in there, you'll see more of a computer cartoon type presentation of the actual position of the track. So that's the actual position of the track overlaid onto the terrain. And we can look at this from different angles and perspectives. We have what we call this orbital view. So it gets a bit spinning, and I'm not going to leave that on there for long for the risk of somebody having vertigo by watching this thing spinning around all the time. But I'll go to this free view, which will basically let us see where we are. So we can see a digger there, and we can see the track. And at any point in the solution, we can change our perspective. We can move around in the site. We can view the thing from any angle, and we'll see some examples of how this is used in a second. Now, another key element of the solution is really the schedule. And the schedule is a time and distance plan where it's a chart where on the horizontal axis we have distance in chainage from a reference point within the site. And then down the left-hand side we have time. So in planning activities that are going to take place within this project, we simply click and add an activity for a particular resource to perform a particular function. It's fairly simple stuff. So before we can do any of that, we need to see our resources. So what I'm going to do, I'm just going to take the schedule away for a second, and we'll actually just look at what resources we've got available here. So I may want to add a new one, but we'll just have a look at this thing called the scrap collection train. And as I just expand that, we'll see that the train that we're talking about is made up of a locomotive and 4 Falcon wagons. And actually, let's just display the thing in the graphics. So if I go to there, then we just quickly switch to our orbital view. We should get a clearer view of it. Yeah, there it is. So there's the train that we're talking about, and I'll just let that thing spin round so we can see what's going on with it. That's probably enough. Okay, I'll just stop it there. Okay, so if I wanted to change this resource, if I wanted a different type of train with some different components, I could go and add a new one, but for simplicity here, I'll just modify this one. So if I wanted to add in, for example, a Kirov into that particular train, I could add it in, and I could position it within the thing, and then if I apply the changes, we see the graphics modify there and then, and we can see that resource. So we can put together any combination of resources that are then used for our different activities. I'm going to take that one out for now. And we've got a library of about, I think, 20 different types of equipment that are used within the projects at the moment. But as the different projects come to us, we typically find we need something else, and it's fairly quick and easy for us to add in new resources into the library that we have available. Okay, so that's resources. And then when it comes to actually defining what they do, we have the time and distance plan. So if we look at, for example, this action that says position digger. In fact, actually, let's look at this one here that's in red that says scrap on it. I'll just change, I'll just zoom out slightly so we can see what's going on. Because we've got activities going on in parallel, so the text kind of overlays there. But if I just double click the action on the time and distance plan, we can see we have an action which is for the digger, that's within our plan here, It's called scrap, and it's got an action assigned to it which says scrap the whole track. And the planner can choose from this library of different actions, whether you want to scrap an individual rail, to install a new rail, to add top stone, to add ballast, whatever you want to do in there that's related to track engineering, you can select from this palette of different activities. We then specify from where and to where it takes place. So it's greyed out here in terms of where it starts because the thing did something else previously. It knows where it is, so when we plan a new activity, it starts from that particular position. And we can specify where that activity is going to end. So the track in question of the 2 tracks we have running through the site and a chainage point. Also, what you can actually do is click on the little icon there and then select the 2 locations from the 3D graphics rather than to enter a chainage distance. Then we specify a time, or what we can do is we can build in project dependencies. So this one is set to only start when it's been positioned in the site, and also when the related collection train has also been positioned into the site. And we can go and build in delays. Yeah, so we can specify it start a period of time after something else. So this is how we construct the plan, and that's what gives us the time and distance chart that you see there. So what I'm going to do now is I'm just going to play the action in a moment. So I'm just going to select that point, and you can see I've got the red line indicates time. So as we actually play the action, you'll see the red line time slider move down through the chart as time advances. So if I click play, you'll see the digger start to move. And if anybody feels queasy, please shout, but I'm going to go to that view. Yeah, and actually I'm going to speed it up because we only have a certain period of time, and there are other speakers after me. So we're going to let that thing move through the site, and we can see as it progresses. In a moment, then the next activity is this train is going to start to position. And it's highlighting a blue section of the track there as I just hover my mouse over the particular action. So the train will arrive in the site. Actually, let's just increase the speed a little bit again. Okay. And then in a moment, what we'll see is the scrapping of that particular section of track. And because we chose scrap track, we'll actually see that begin to occur within the scene. So as the digger moves away, yeah, we can see the track begin to disappear. Yeah. And then it'll continue working like that, and the various pieces of equipment will move through the site. So how is this actually used in practice? Let me just pause the action. I'll let the action play a minute. It's proved to be very useful for clash detection, of figuring out we can actually get the equipment into the site. It's also been useful for removing some of the need to carry out a survey. Yeah? We can actually see what's going to happen and get a good idea of it before it actually happens. It's also useful for actually figuring out the relationship of the equipment to the physical environment around the actual track itself. So if I just pause it there, and let me just stop it from spinning round, actually. You can see in the scene we also have, there's a free view, we also have these catenary masts. So I was interested in figuring out the clearance between the digger and that particular mast. Yeah, I could allow it to move forward a bit further and get a pretty clear idea of the amount of clearance we're going to have in that particular instance. We've also found it to be quite useful for safety purposes. So it's been used by the stakeholders that are specifically responsible for health and safety, ensuring adequate clearance between personnel working in the site and the machinery to figure out actually what that's going to be like in practice. I'll talk more about the benefits later on. So as well as actually building the simulation of how the project occurs, we've also started to look at some other aspects. So one of those is costing. Well, because we have now defined information about the assets we're going to use and how these assets are moving through the site, we can actually begin to associate costs with each of the financial costs with each of those activities. And then we can view this kind of, the numbers are fictitious, but we can start to view the time that each of these resources is used and see the cost and see a totalization of those costs also begin to appear. We've also started to build some functionality for editing the layout of the track, so the layout of the track changes through the course of the project. we can toggle into an editor mode. If I just can select the right option over here. Okay, and then we can actually go into a track editor, and we can select each of these tracks and actually then begin to actually change the layout of them, add new tracks into the site by drawing onto the scene to model actually what's going to happen within the project. Okay, so that's broad, that's a quick demo. We could probably spend longer talking about it, but that's a quick demo of what's occurring within the solution. I'm going to toggle back now to the presentation PC, because there's a couple of other things I want to talk about. Okay. Other functionality we've implemented recently was an integration with the Primavera system. So we now have a file export, so all these activities and tasks that we create for the project plan can be then exported in a format that then can be imported and used in other systems, either for costing or other kinds of purposes. We've also begun to implement functionality for other disciplines. So signals, OLE, welding, drainage. Yeah. So far that's got as far as simply being able to mark out areas of the track where other kinds of work are occurring for a period of time. But we're moving on to be able to do more with that and incorporate other actions in our library of tasks to model those activities. And then a third one here, which actually is really in the closing stages of development, is integration with point cloud data. So we have a relationship with a company called Fugro, who actually one of the exhibitors who you can talk to in the coffee room out there. They provide a system called RILA, the RILA portal, which is a point cloud data providing more accurate modelling of the rail environment than is currently available to us for building our models from the GeoRINUM system. It's captured using LiDAR, so devices mounted on trains that capture really accurate point cloud information, like running trains at normal operating speed through rail corridors. So what that looks like, to move to here, is I'm just going to play a little video to show what happens. So what you see in the scene there, if I play the video, is from a given location within our software, a user can select an option to then view that particular spot, that particular location within the RILA portal. When the video gets there, we should see. There you go. So the user chooses the option to open that location in the RILA 360 system, and that gives a point cloud view. The user can still toggle and move around and see what view the perspective, and can then start to perform measurements, which now are much more accurate than would be the case from the data that we have available currently from the GeoRINUM system. So that's just an example of the kind of integration that we can do using this technology to provide more functionality and benefit for users. We have a fairly extensive roadmap for how we're going to take this forward. We have something like 300 points on our roadmap of things that we'd like to do. But some of the priority items are, as I've mentioned, improving the simulations for other kinds of work. So the focus very much at the moment is on track and track renewal. But extending into those other areas is quite key for us. We want to enhance that costing functionality. It allows to account for costs relating to the use of machinery within the site, but that's only half the story. It doesn't account for raw materials. Doesn't really understand about shift patterns, so there's some key aspects to the model for costing that we want to improve. We want to improve the support for multi-user teams. So currently the way these plans work is a user can create a plan. It's much like working in Microsoft Word, where you work locally on your document and then you can email your plan to somebody else and they can also work on it. But we want to allow teams to work together at the same time on the same plan. But we plan to improve the animations, for example, the articulation of the digger arm and the crane, so we can actually see more information about the clearance issues that those pose within the project. And also a very technical sounding feature, but one that adds a great deal of flexibility. We plan to allow users to be able to add other assets into the railway environment, the simulated environment, by having access to a CAD file and saying that at a certain point in the project that item appears in the scene, so that we can actually model a wider range of activities taking place on the site than we can cater for within our library. So we can carry on enhancing and developing our library, but that function would just make it much more flexible to do other things with. So those are some of the aspects. And coming to the end of the presentation, now benefits. We've actually seen an 80% reduction in the time it takes to plan the project. So I think there's a 56-hour possession that would have taken normally 2 people to work for a week and create the detailed plan with all the staging diagrams. That was achieved in the space of a morning. So it's substantially quicker to actually create the plan. We've seen benefits reported in terms of safer projects, greater confidence in removing conflicts, and also smarter planning. So by seeing what's actually happening, you can de-risk the overrun. You could analyse the data on Gantt charts and on staging diagrams to your heart's content, but there's nothing like seeing it to really understand what's taking place. We believe this maximises output and also optimises the use of resource. So that's where we've got to. We have some plans for it. And we're keen to engage with other organisations specifically in these other disciplines. So we have access to some good experts within the university, but we're always looking to engage and get input in terms of this roadmap and functionality from other people who have interest in other disciplines. So thank you very much for listening. That is the end of the presentation, and I'll see you later on when we come to questions. Thank you.